Hey Paul,
Hi, JJ.
how's it going, buddy?
It's going great. How are you?
Good, man. I'm excited today because we're picking up from where we just left off. So if you watched our first video, this shouldn't be too changed. But before we go anywhere, who are you?
Yeah, I am Paul Tchaikovsky. I am a managed services black belt at Red Hat. And that's a fancy way of saying I help our customers consume our managed services such as Rosa and ARO.
What's Rosa?
It is Red Hat OpenShift on AWS. And so it's all the all the usefulness of OpenShift without all the pain and suffering of installing it and keeping it running. Uh, we do that for you because turns out Red Hat's really good at running Red Hat products.
And follow up, Arrow?
Same thing, but on Azure.
There you go. There you go.
Yeah.
People watching this video because we're going to be talking about AI. They probably have no
Right.
idea what those things are, right?
Yeah. So that's a good point. So basically, so the IBM and Red Hat AI products run on top of OpenShift. And
Mhm.
so if folks were interested in using either Red Hat OpenShift AI or Watson X, under the hood somewhere, there is an OpenShift cluster, and you can decide if you want to run that yourself or just ask Red Hat to run that for you. And it's actually because of the economies and scale and expertise that Red Hat has. It's actually significantly cheaper in most cases. I shouldn't say all cases because there's always weird exceptions to have our experts run it for you. So not only
Nice.
do you get people and systems that are experts at running it, but it usually comes at a hefty discount. And you buy it directly from your cloud provider, which means if you have guaranteed spends through your cloud providers programs, you can actually burn that down to run the OpenShift and other Red Hat products. So that's kind of cool.
Nice. Nice. See, I give you opportunities to plug things, Paul.
Yeah, yeah, you do. I appreciate it. Hey, speaking of plugging things, I'm up in sunny Montreal right now. Have you been to Montreal before?
Uh, no, actually, I have not.
Yeah, so it is like New York and Paris
What?
got together and had a baby,
Really?
and that baby is slightly more attractive than both of its parents combined.
That's saying something.
Yeah.
That's
Uh,
saying
yeah, so we have Montreal smoked meat, which is delicious. It's similar to pastrami, but they get
something.
mad if you compare it to pastrami here. It's made from whole cuts of brisket, whereas pastrami is usually made from belly. I don't know why I'm going into so much detail, but it's delicious. And they also have Montreal style bagels, which are different to New York style bagels, and are
Mm.
also quite delicious. So I highly recommend it as a destination to go and eat delicious foods.
So, because I'm an American and I don't know
Oh,
locations,
Montreal is in Canada.
yeah, yeah, I got thanks. I got that much.
You're
But I
welcome.
don't actually know where. So, just for people watching, here it is. It's in Quebec. Just to make sure you realize. Like I was like, why is it close to New York? Oh, it's in Quebec. That makes sense. I hear there's good fishing in Quebec.
There is good fishing here. I actually got a friend here that is upset I didn't give him more notice because he couldn't take me out fishing.
uh, the Letterkenny joke just fell flat. But it's fine.
Oh,
All right. Yes. Yeah, it's fine.
and who are
Hey.
you?
Yeah, exactly. Hi. My name is JJ Asgar. I'm a developer advocate for IBM, and I am elbows deep in the InstructLab project, and that's probably the reason why you're watching this video because hopefully I put the title down as InstructLab Paul and JJ learning InstructLab Part Two or something to that effect. We'll figure out what I actually put down in the future. But yeah, I'm elbows deep in this project, and Paul is been asked me a bunch of questions about it, and it turns out we have a we've streamed a lot in the past, so why not just streaming Paul learning how to do this with me kind of riding along shotgun or driving, depending on the situation. Um, so just a quick little recap of last time we did it. We did the previous video. we did some very good high overview stuff about InstructLab, which we'll probably end up touching in just natural conversation again here. So if you want to watch it, it's in probably a playlist somewhere or whatever. Or maybe if I'm smart, I got the little box thing that pops up on YouTube here. And then we also actually installed InstructLab on a machine at the very tail end of it. And I, as promised, have not touched it since then. So if we take a look here, give me a second. And as said as many times, and I'll say it again, if anything pops up while I'm doing this embarrassing, I apologize ahead of time because I'm sharing my whole screen. But Paul, there's a question you like to ask all LLMs when you first start. You want to type that in there for me to show that it is actually up and running?
Who is Batman?
So what Paul has done there, he's used the iLab chat command, which is already open, as you can see there on the bottom pane. And we're talking to the Merlinite 7B lab quantized model at 4Q. And it knows who Batman is, which is pretty cool.
Wonderful.
Yeah. Yeah, great. Oh,
Well, that's exciting.
yeah.
Wow, you were born in 1996.
Yes.
I wonder if this
Oh,
person's real or if it's hallucinating.
it's got to be hallucinating. It's like when I
Right.
asked, what is a developer advocate? And it told me
Oh
I
boy.
worked for President Obama, traveling around the world, finding assassination targets. I was
Oh,
like, well, I mean, I do travel around the world. I guess
I mean
part's true.
that's more of your hobby than your profession, right?
Exactly. But no seriousness. That's actually a really good sign. A good place to start this conversation is that when an LLM does not know about something, it hallucinates. It just because it's trying to figure out what you're looking for, and there's probably somebody in its little knowledge base, which is the model that has something close to. It's probably thinking of J.J. Watt, right?
Right.
And it just played off of that. Though notice that it did say Oakland Raiders. Oops. Yeah, Oakland Raiders there, um, which is interesting because what is it doing when an LLM finds it's looking for the next word. It doesn't figure out the answer for you all at one time. It goes word by word by word, or token by token by token to
Yep.
be specific. But in this conversation, let's say word by word by word. So that's the reason why it'll keep asking. It looks for the next word every single time. So that's why it comes out in that little chunking way. You can play with it because, as we discovered last time, what is today's date? It'll actually say the wrong date multiple times because there was something inside of the vector or the data set that it was built off of to know what day it is. So this one should be completely different. Well, I mean, it is a day different, but you get the point. So,
Yeah.
um,
I actually have a thought, JJ.
sure.
So it's a shame that this large language model doesn't know who you are because you really are kind of a big deal. So how about this? Next time we get together, we teach it who JJ Asgar is.
So that is very flattering, Paul. It turns out to do a knowledge submission requires a little bit of work. One of the things, and that was going to be the second part of this, is that we were going to work with Jason Kelsey and use some Q&As to build off of that because we need a markdown file that
Mm-hmm.
will be able to go. But we will go into details about that momentarily. Um,
Okay.
Before we go any farther, though, I do want to pivot real quick because something that we hopefully you've noticed here is that we are talking to the Merlinite 7B quantized model. Right now, our project has, right now we are supporting, at this recording time, this exact moment in time, we are supporting two different models. The Merlinite model, which is built off of the Mistral model that we forked and did some work inside of, and we also have something called the Granite model. The Granite model is open source from IBM, and it is a foundational model that is very stripped down, which is actually a great way to prove the InstructLab workflow, because we have to teach it so many new things. So we can take advantage of that. But an important recognition here is we don't actually have granite on here, because by default, iLab just pulls down the Mistral model. So what we need to do is pull it down. So I have a command right here. Matt, if you're watching, thank you so much for putting this in my notes. You just made my life significantly easier. We can go ahead and grab this. And as you can see here, we iLab download the repository of InstructLab Granite GGUF file name, which if you notice here also, it is a quantized model. And then we put it inside the models directory. Now you're probably wondering where I get this InstructLab thing from. And it is actually directly from, hopefully this works. No, because I'm not sharing my screen. Give me a second here. Send something else. Window. Computers are hard. Bear with me. Entire screen. There we go. That is from Hugging Face. So we can actually take this direct location. Sure. Pop it in right here, and you'll see we go directly to the 4-bit quantized version of InstructLab Granite Lab here. So we've already talked about quantized once before, Paul, but let's talk about it again, because we do touch on it quite a bit. And well, hopefully people watching this video understands that what we are running is not the full model, and we're running the quantized version of it. What does that mean to you?
Yeah, so when you quantize a model, you're compressing it in size, and you are losing some accuracy. So I think last week I kind of made it, I kind of compared it to movies, right? You have a raw unedited movie that is, 100 million gigabytes, or whatever size, and you turn it into an MP4 or a MOV file, and you say I only want 1080p, and I don't care too much about image quality or audio quality. And so it not only compresses it down by finding all the repetitive bits and kind of replacing them with smaller patterns, but it also reduces the quality of the image and the audio, which can result in interesting artifacts on the screen. In a quantized model, it kind of, I don't know, it's not that it gets stupider, but it kind of loses information because it has less overall tokens, and therefore some of the tokens that used to be close together may no longer be close together, and other stuff. So it tends to give less accurate responses.
That's a better word for it, is less accuracy. And for the lion's share of conversations, especially for the target audience that we're talking about here to watch these videos, yes, it just gets dumber, right?
Right.
It does, because you're chunking off a huge bit of its brain to be able to get it to be a reasonable size to run in memory. Something you need to recognize about these models is that for them to be effective at all, you need significant memory size and significant GPU or CPU power to do it. And the full Bloat 32, which is, from what I understand, the unquantized version of the model, that requires an insane amount of memory. And we're talking like 16 to 17 gigs, or so, no, sorry, 16 to 24 gigs of memory on a GPU.
Right. Which, if you've looked at consumer grade GPUs, to get that kind of memory, you're looking at $1,000, $1,500.
On the
I think,
budget side. On the budget.
that's right. On the consumer facing, like, gamer side, that you can kind of also use. If you're looking at actual proper, like, server grade hardware, you're suddenly talking about tens of thousands of dollars to get this stuff. So it is not cheap. However, you can take some older consumer grade GPUs. So I have NVIDIA 1080 TIs, I think they are. And they actually, I've got two of them in a box. So I get 8 gig of
Mm.
total memory. And
Mhm.
I can run a couple of models quantized down quite effectively. The
Mhm.
first time you ask it a question, it takes a lot of time to load it into memory, but then it becomes reasonably
Mm.
peppy.
Nice.
So for folks that are interested in running this stuff at home, if you have a Mac with a like M2 or better processor,
Mhm.
that actually can share system memory with the kind of inbuilt GPU,
Mhm.
and so you can get some decent performance there for InstructLab and also other uh, LLM tooling. There's new and interesting chips coming out. So the newest Intel and AMD chips have things called NPUs, which
And-
are neural processing units,
Okay.
and they don't quite work the same way, but I believe people are starting to make models specific that can work on those NPUs. And then there's some other um, ARM-based stuff coming out in the consumer world that also might be useful. But right now, the best thing to do is, if you're really interested in it, get an NVIDIA GPU, similar to what you play games on.
Mhm.
You'll often see them come up on discounts, especially in pre-built machines from like Lenovo and
Mhm.
Alienware and stuff. And so I actually just saw it was a Lenovo with, I think, a 16 gig 4070 Super for $1,500 for the entire machine, which is quite a bargain. I looked at what it would cost to build it yourself, and I got to like $2,200 before I stopped trying to uh, see if I could build the same machine myself. So
So
yeah,
on that token, Paul,
ah,
inside the InstructLab Slack channel, I do have this builds. I mean, it's very empty right now because people don't want to give me information. But to Paul's point right there, this was Ben Browning, who helps me out with the office hours. This is the one he builds off of, which is a nice one for about $2,500, and he's able to do quite a bit of the InstructLab work on top of it.
yep.
But to highlight Paul's point about a moment ago about the GPU that could actually run this on the budget build is $1,300 just for the GPU. So if you have thoughts or suggestions, please jump into our Slack and ask for this sheet, because I would absolutely love to add more to this, because people are going to ask this question over and over and over again, and not everyone can afford to go buy an Mac M3 right now, right? Those are expensive. So I just want to make sure that was known.
Yeah. So if you look down at the money bags build, you haven't got one there, but there's a guy on YouTube. I think his name is Network Chuck, and he did
Oh
a
yeah.
video. He did a video of building out a local AI machine,
Uh-huh.
and I think he has four of those 4080s in it. And I think it looked like he spent like, I don't know, 8 grand or something building this thing out. So it's definitely the money bags build. But it was doing like stable diffusion images in
Oh wow.
like a second like that. It was pretty cool to see.
All right. Well, I will go steal that and put that in there, and maybe even put a link to his video. And
Nice.
I do like Network Chuck a lot. I've learned a lot from him too. So if you know him or whatever, tip your hat to him for me, will you? So all right, let's go back to where we were. Uh, Here we go. So as you can see here, we pulled the model down, and now I'm going to use iLab serve to serve the Granite model. I believe that's all I need to do. That's not what I needed to do. What was it?
Whoop.
Model path. Uh, path. They changed it on me. Okay, so there we go. Now we're up and running again. So if I can come down over here and then to streaming, InstructLab, and then VNV. Nope. Source bin. Source VNV bin. It's because you're watching me, Paul. I can't type.
Yeah.
iLab chat. And as you can see here, we now at the very top here know that we're using a different model. This is a good way to do this. If you didn't know also, iLab chat is a OpenAI API compatible client. So if you're using something like VLLM or another OpenAI server that is not OpenAI, but it's like one of the open source APIs for is OpenAI compatible, iLab chat can actually point to that. Just to make sure everyone sees, you can do. Oops, you can do iLab chat help here. Help
Plop,
here.
plop,
Exactly.
plop.
You can give it the endpoint URL right here, and
Oh,
it'll
nice.
hook directly to that.
Could I actually just point it at OpenAI and use GPT 4.0?
So that gets a little weird. I would say that it is in if you're willing, like if you are watching these videos, I would say that there's a few steps you've got to step through. But Paul, if you sat down with a beverage of your choice, you'd probably get it to work relatively quickly.
We'll be able to figure it out. Okay, cool. Yeah.
There's a couple of hoops you got to jump through.
Okay.
All right. So who is that man? Now, hopefully, you've already recognized something here.
Um, what have we noticed?
Well, first of all, it's correct, which is nice.
Right. It's nice.
But the interesting part is that it's worded differently because it is a
Mhm.
different model. And the original way we asked who Batman was, the first thing the Merlinite endpoint gave us or model gave us was it talked about Bill Finger first, right?
Right.
Which is the original creator of Batman. Where this one actually went through the comic book side of it, which is a different way of the model interpreting what you are asking, right? So that brings us into the conversation of when you interface with models, you need to think about how you ask your questions, right? Like the whole prompt engineering thing out there. Um, but it's really important to know how you ask these questions and build off of those to be able to do that stuff. Does that make sense, Paul?
Yeah, it does make sense, and I've definitely noticed this. It tries really hard to answer the question that you give it, right? Which it makes sense, but what it kind of implies is if you ask a question, it tries and gives you like the positive answer to that question,
Mm-hmm.
and so your own biases in the way you ask questions are then reflected back to you in the responses. And
Yes.
so that's where, sometimes the way you ask a question, um, you know, can I eat glue? Right? It's going to try and tell you that you can eat glue because that's kind of what you're asking for. Um, and, then you end up with weird things like it tells you to stick your cheese on your pizza using edible glue and, things like that. So, you know, it's an interesting thing where you do like the better your prompts, the better the results.
Mhm.
And there's a lot of accidental confirmation bias that can happen if you're not sort of really careful and selective of how you write your prompts. Um, yeah.
So to play off of that, here's a nice little actual example. Do you
Yes.
know who Jason Kelsey is?
No, I do not.
Okay. You know what I'm going to do real quick though? I am going to quit out of this because I realize that we're playing in a space that is we needed more screen space here. Um, activate models. Oh, ha. All right. My bad. Okay. So Jason Kelsey. Jason Kelsey is who is Jason Kelsey? Jason Kelsey is Travis Kelsey's brother. Do you know who Travis Kelsey is?
I do not know who Travis Kelsey is.
Do you know who Taylor Swift is?
Yes. Yes.
Okay.
Okay. So
See where I'm going with it.
the other
So
Kelsey is the football that's dating Taylor Swift.
correct. And
And
Jason Kelsey is Taylor Kelsey's brother, who also plays in the NFL.
okay.
So, well, it turns out we actually I'm going to show this here. I'm going to spoil some stuff here, but the interesting part about this is we at Red Hat Summit we had a bunch of workshops about learning how to use knowledge, and this is kind of going to the original question of, hey, can we um, teach the model about who JJ Asgar is? Well, what we're going to do is we're going to teach, or at least going to start teaching it who Jason Kelsey is locally here. And the first thing we need to see is, does it know who Jason Kelsey is? So it knows quite a bit of information about him already, which is pretty cool, right? Actually, it knows quite a bit of stuff about him. That's not what I was expecting. I'm gonna have to talk to Julie about that one. But
Maybe some
well,
of the knowledge that was being worked on at Summit ended up embedded into the model.
not yet.
Okay.
Shouldn't have. But I'm gonna have to bring this one up here in a little bit. But the point being is that some of this information could be wrong, right? So every once in a while, we need to update this stuff. If you've looked at some of the videos about InstructLab from, for instance, Jeremy Aders, he does something about softball, right? And how softball was originally the first game of softball. The model said it was in New York or something like that, but it turns out it was actually Chicago. So he taught the model how to fix that because all these models are built off of Wikipedia and things like that, where occasionally the information can be wrong. So we do need to go in there and fix it and actually have a trail of this through the taxonomy we're talking about. So as you can see here, that's important. But if I go say, what team drafted Jason Kelsey? Oh, okay. I was expecting you to not give me the correct answer there. Let's try that again. Okay. So this is becoming a really bad example of what I was trying to prove. But the idea is I was hoping for it to ask like just find a random Jason Kelsey out there and what team, not specifically the NFL, because my goal was to say what NFL team, to go what Paul was saying a moment ago about the questions you need to ask. You need to be very specific about it, right? So what team drafted Jason Kelsey? Now it knows, oh, I'm looking for an NFL team, not just a hockey team or a football, or if for our European friends over there, team, not just the NFL. It's important. The context of focusing the question is really, really important.
Yeah. So it seems like Granite has learned more about Jason Kelsey since you did this last.
It seems to be. It seems to be. Who is John Smith? Let's try just something very generic. Oh, so it was grabbing context for me automatically because of the questions I'm asking.
Okay.
Oh, this was clever. Okay, check this out. So I started a new session, right? So if you go into /help right here, so by default, I didn't. They've changed this on me since the last time I was doing
Ah,
this. It
because
was
you've had discussions about these people, and it's learning from the discussions you've had.
yeah.
That's keeping history.
Yeah, the questions we were asking, it knew that I was talking about Jason Kelsey. So it's like, oh, I can keep going down this path. So
Right.
because I didn't change the context, last time I used iChat, or iLab chat, this was still experimental. So this is really cool. They've actually got it working now. This is really cool. So let's try this again. So let's brand new session, talking to the model. Who is John Smith. Okay, so what sport did John Smith play? So as you can see, because we asked, we started here, right? We see where I'm going with this now.
Yep.
It is a renowned author, skilled athlete, high-ranking government official, and notable historical figure. All right, what sport did he play? Okay, now you're asking about sports. Okay, cool. Professional athletes like baseball, basketball, football, golf, and soccer, right? So now, um, what
You could say what
uh,
football team?
team did John Smith play on? Okay, so it needs a little bit more specifics, right? So we'll go with what
What
NFL
NFL?
team? Yeah. Okay. You get the point, right? So what we've accidentally done here is shown the advantage of prompt engineering, right? And the ability to make sure that you ask the correct questions um, to be able to build off the correct things. So when you start playing with these different models, you can focus them in. In NFL. Wow.
Well, you can conduct your own research.
Yeah.
AI, I want you to do my research for me. But this is actually good though, right? Because it could just like hallucinate something up or just pick a random
Hmm.
one and tell me about that one.
Yep.
But it's you know, kind of just saying, hey, it's a lot. I'm surprised there's that many John Smith players in the NFL.
Yep.
How many
Oh, there
John
you go.
Smiths played in the NFL?
Oh, boo.
All right.
Yeah. There's probably a way we can probably eke this out, but we're not going to sit here and just hack on it.
Who
Um,
is the Kelsey guy? Jason Kelsey?
Jason Kelsey. Yep.
Yeah. So it still knows about Jason Kelsey.
Yep. So, my next goal of this was to actually start showing off, because my plan was is I thought Jason Kelsey was completely missing here, but it turns out I was wrong. But if you take a look here, this PR right here, which is 1144 here, has become a very good example of the what we call the Q&As, which I guess we'll go over next time because we're already coming off close to 30 minutes here, if not longer already. So we can do that next time we do it, where we actually start giving it new knowledge, right? So the advantage, so we understand that the Granite model doesn't have everything in the world inside of it, right? It's a foundational model. So you need to be able to give it new stuff. And what we've done with this project is we created something called Q&As that you can ask it simple question and answers, just like we were talking about last time, right? Yes, I know it says answer first and then question. It's a different conversation for a different time. Um, but you can ask it these questions, kind of being like uh, when you get a textbook and you have a chapter, right? At the end of a chapter, you have a bunch of comprehension questions, right? To make sure you're understanding. You have a bunch of questions and you have the answers to be able to go for your teacher or whatever. Well, it turns out we took that exact same model and created a way to ask these questions, and then it points to a specific markdown document at this exact moment in time. Right now, we only support Markdown on GitHub. So you post this up on GitHub with a bunch of knowledge about the thing. and or a bunch of statements about it and whatnot. If you want to take a look, we can just bring it up real quick. Hang on. Right now, they have to be coming from Wikipedia due to copyright laws, et cetera, et cetera. But if we come to Jason Kelsey's here, Julia here has gone ahead and I can't spell Jason Kelsey, actually cleaned up the Jason Kelsey Wikipedia article, pulled out all the different charts and pictures and all, and just put the text in here, right? So what the knowledge does is it scripts it in, knowing exactly which version of the commit, which is very important because we want to be able to trace back to that knowledge. And then we train the model via these types of questions and create thousands of questions using the iLab generate that are based off of these types of questions, not these exact ones, but based off of them through another LLM. And then we train the model with those thousands of questions with that. And then when it's done, our system actually asks these questions, which is never seen before, that trained model, to make sure that it's got the correct answers, which are the answers you expect here, right?
Right.
Which gives it
So
a way for...
question then. So basically you end up with one model training the other model. So it's I assume it's the larger model, the Merlinite, that does the training. So
Correct.
it looks at the source document and it looks at your questions and it's like, okay, I'm going to create 1,000 more questions like your questions that are going to interrogate details in the document. And then it's going to pass those questions and answers to the the Granite model.
Mm-hmm.
The Granite model now learns those. Does it pass the source document as well, or just the questions and answers?
Good question, and I don't know that off the top of my head.
Okay.
I believe it does read from the source document, but I don't think it gives the source document to the student model.
Right.
It just gives it the questions and answers to be able to interpret it.
Right.
And
Got it.
important to recognize what Paul just asked there. The model that is actually going to do the generate is that Merlinite, as you can see right there.
Yeah. And then once it's been trained on all those questions and answers, it then goes back and asks the original set of questions you give and verifies that it gives the correct responses. Yep. Does it have to be word for word, or is it smart enough to kind of say, okay, you've given the correct answer, even if it's not the exact wording?
I believe it gives the easiest description is the spirit of the answer correctly.
Mm-hmm.
And there is some mathematics that I will never understand that helps with that stuff. And then what happens is we do this locally. And again, these are all just quantized models, right? That's important to recognize. And we're coming close to the end here, so I'm going to go ahead and stop sharing my screen here.
Question. So you mentioned it's quantized models that you're doing the training. Does this mean that before you start doing any training, you should ask the unquantized model the questions to make sure that you're not artificially making it inaccurate, so that you can then teach it stuff that can then be taught to the model that already knew it upstream?
Spoilers, Paul. Jesus, you're just killing my whole flow here.
Yeah.
I will answer that. Yeah, I will answer
Hey,
that.
this means you're teaching.
Yeah, exactly. No, you're catching on, which is amazing. So remember, these are quantized models. So the questions that you're going to ask and the knowledge you're going to give it, there's a strong possibility that it will be missing. Now, at this exact moment in time, we have the full model running in certain locations for certain engineers to access. We have not opened it up publicly because it obviously costs real money to run these things. But we are discussing ways to give people access to the full model. So if you do find something inside your local quantized model that isn't working how you expect it to, and you've trained it and now it knows about this thing, before you push it up to do the upstream version so it gets pushed into it, there will be ways for you to access the full model to see if it's already there.
Cool. Okay, that's a good point, because I can download and use the quantized model on a decent GPU machine, but I could probably not do the same with the full model. So
Correct.
what you're saying is there'll be some sort of chat GPT like interface
Yep.
that's just running the full Merlinite and or Granite models that I can ask it questions before I then go to all the effort of, okay, makes sense.
And I will say it is happening very soon here. I've already seen the POC of it from my friends Anil and Brent, and it is very natural. The problem is and I want to reiterate this costs real money to run, and this is an open source project that we have to think about the budgets for it.
Yep.
But we will find an answer, and we will find a way to give it out respectfully to both budget and user.
Nice, nice. And I imagine it will all be running on OpenShift AI or What's Next.
Of course. Why
Nice.
wouldn't it be?
Right. Now, I have a question. So these models are up in Hugging Face. Hugging Face is something along the lines, it's kind of like GitHub, kind of like the Docker registry, but for LLM models, right? And
Okay.
so while we were talking, I looked up Granite model on there, and it said it was last updated 18 hours ago. So I'm going to guess that if we had have done this 2 days ago, it might not have known who Jason Kelsey was.
Yeah, it's very strong possibility.
Are these LLMs models, are they versioned or tagged that we could have gone back and said, give me the previous version and worked on that?
So Paul just kind of like playing with the iLab chat, talking to OpenAI to get that working for you wouldn't take you too long. But for the mass majority of people out there, there's some very strong developer nuances to be able to roll it back to an older version to be able to get to work. It's not as simple. Excuse me. It's not as simple as moving a Git SHA, unfortunately. There's a little bit more nuance to it. There's a little out of scope for this conversation. It is possible, but it is more of an advanced topic.
Yeah. Playing around with Olama, which I think has its own registry.
Yep.
They definitely have model tags, and you can specify the tag of the model. It looks surprisingly like Docker as far as doing like a
The
Docker
model
pull,
file,
right?
yeah, it
Right.
really
And
makes
then they
sense.
have exactly then they have the model file that you
Yeah.
can create an agent and customize kind of the how the agent talks, which is actually kind of fun because uh I was integrating it with Home Assistant,
Mhm.
and so I said to it, you are Jarvis from Iron Man that I have put in charge of managing my the automation in my house.
Yeah.
Answer all questions as Jarvis. Focus on the information being passed to you from Home Assistant and keep it brief. And then I found a voice file that sounded a bit like Jarvis. And
Nice.
then I was literally talking to Jarvis from Iron Man. It got annoying really fast. So I then turned it all off, but it was kind of cool. And
Nice.
that's all done by modifying the model file where you kind of just kind of telling it, you're not really changing the information in it, you're just changing how it presents that information. And you can set things like the temperature, so its
Mhm.
likelihood to hallucinate and some other stuff. Actually really fun.
Nice, man.
Yeah.
Nice. Good stuff.
Yeah, and also
Uh,
what's fun with Home Assistant integration is because you're tying together like 3 or 4 different things and different AI models and stuff, because you have like speech to text, which is I think Whisper, then you have processing that, which is something like local AI or Olama.
mhm,
Then you have text to speech, which is another AI thing, and then you have some sort of wake word, which is again something
mhm.
listening. So it's cool to see a pipeline of different like AI things sort of used in conjunction to
Yep.
give you what's effectively like what Alexa would give you, but isn't necessarily reporting back to Jeff Bezos about your habits.
Absolutely. And also you touched on a point that a lot of people are starting to have real conversations around, is that these massive models, as we've proven by the requirement to run just the main model that isn't quantized, running massive models isn't cost effective. I mean, you might want to write like one to do like the teaching system of what we're talking about, but you're going to want smaller models that are focused on specific jobs. And then just like microservices, because we can't get away from Kubernetes. That was supposed to be a joke. Um, we're just creating microservices of models out there that focus on very specific things.
Yep.
So it does bring in the conversation of good guardrails, because if a micro model, if you will, micro model, um, doesn't know about something, it will hallucinate. So you need to find a way to make sure that it doesn't do that. But
Right.
I see exactly what you're going for, and that is exactly how we're moving forward.
Yeah, and it's actually really exciting that we're moving in that direction. One of the things, and I saw someone talking about this the other day with the way OpenAI works, and with that is like Copilot and other stuff. Is for Copilot to do code, it doesn't actually have domain knowledge about specific languages, like programming languages, etc. It just has the entire internet jammed into it, including GitHub.
Mm.
And they actually have a bunch of hacks to get, because the OpenAI LLMs are focused at like human language, right? Not, not programming language. And so they actually have a bunch of hacks to get it to be able to appear to have that domain specific knowledge about
Oh.
programming languages. And so they have these hacks in how they encode like new lines and tabs and stuff in your languages, which is kind of interesting, right? Whereas if you take something that is domain specific, like you can say, hey, here is my Python domain, and here is my Fortran domain. And now I can take a model, give it both of these contexts, and ask it to convert like Fortran to Python or something. And it's going to have, my understanding, is going to have a much better chance at being successful at a smaller size, because it only needs enough English language to
Yes.
be coherent enough to answer, to like understand questions. And then it's able to pull from the knowledge it has from the specific programming languages.
Yeah.
And so you can end up with much smaller models that are much more accurate, which makes them more accessible to people that don't have giant GPU farms. And that's not just like,
And faster.
that's not just home people. Like, it's cool that
Yeah.
you or I could run this stuff at home, but like it's also like companies, right? Like how many companies have the budget to have hundreds of GPUs sitting in a cloud or in a data center, just sitting around idling, waiting to be asked a question?
Exactly. 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 That's great. But
Yeah,
yes, that is awesome. That
yeah,
is awesome connection. That's great. Awesome. Cool. Well, I guess we're done for now. Which is good. Uh, I don't have outros because I've never been good at them. But I guess we'll go do this again soon, Paul. Yeah.
yeah. Let's try and figure out a way we can actually have a model not already know the answers to the questions we're
Record.
asking. And yeah, we'll maybe try doing this training step again. I still think we should teach it who JJ Asgar is. We can't do that locally without messing up the upstream GitHubs.
Yeah, it gets weird. It gets weird
Okay.
really fast. But it's a time for another. It's we can do that some other time. We'll figure something out eventually. It'll be fun.
Sure.
It'll be fun.
Okay.
All right, buddy. I will. I'm gonna end the recording. I think as soon as I figure out how to do it. Let's see.
And
Stop recording.
recording.